Fast Fourier transformation, brief as FFT, is frequently applied to decompose a time sequence measure signal into a frequency spectrum to reveal any hidden mode of the measure phenomenon. As we often acquire the transducer signals via LabVIEW, this lab shows you how to perform FFT in a LabVIEW with time signals in different sampling conditions, so that the superposed phenomenon can be understood. Fourier transform is commonly used in signal processing to convert a time domain signal into a frequency domain spectrum. In this experiment, we will apply fast Fourier transform to signal processing. X and XA are the spectrums from fast Fourier transform of two different signals. Aliasing happens when the sampling frequency is too low. And aliasing may lead to a coincident spectrum with a different time domain signal. Aliasing can be eliminated by increasing the sampling rate to twice the original signal frequency. Or by using the anti-aliasing filter to filter the high-frequency part of original signals, which exceeds half of the sampling frequency. Window function produces a constant only within the desired interval. It is usually applied to original signals to extract the desired segment for fast Fourier transform. We can preserve one segment of original signals by multiplying the window function. Apply fast Fourier transform to the original signals and the window one. We can obtain different frequency responses as shown in the plot. From this plot, we can observe an improper signal processing length, leading to leakage error. It can be eliminated by increasing the sampling length or applying different window functions. Assume we observe the original signals at certain instants with a constant interval labeled on the time axis. The points on the time axis represent the timing of capturing the signals. The constant intervals denote a constant sampling rate. We can imagine that we actually observe the original signals through a picket fence. We may mistake the correct amplitude if we miss the true signal peaks. The resulting distortion signal is known as the picket fence effect and can be eliminated by increasing the sampling rate. Here is a look of the LabVIEW panel. The first block shows the composed time domain signal. The second block shows the applying window function. The third block reveals the resulting signal by multiplying the original signal with the current window function. The lower left block shows the fast Fourier transform result for original signal. The lower right block shows the fast Fourier transform result for the window signal. In this experiment, the original signal is composed of three waves. The first row bottoms define each waveform. The second row is to adjust the frequency of each wave. The third role is to adjust the amplitude of each wave. You can also apply different window functions and observe its effect on the fast Fourier transform results. You can observe entire spectrum by switching on the Mirror Spectrum button. Filters can be added to your original signal with the chosen cutoff frequency. Number of sample and sampling rate can be altered through the input windows beside the Stop button. You can turn on a single degree of freedom mode and change the damping ratio and natural frequency. This lets you observe the time and frequency domain response of a mass spring damper system of single degree of freedom for future applications.